Okay, so for the number 1 and number 2, we're going to factor the denominator and then figure out what our least common denominator is and then multiply the entire thing by it. So if I look at number 1, the first denominator would factor to be x minus 2 and x plus 1. The second one, x plus 2 and x minus 2. The last one, I can take out a 2, and then it'd be x squared plus x minus 2. So 2x plus 2x minus 1. So least common denominator here is 2, x minus 2, x plus 1, and plus 2, and x minus 1. So from the first fraction, the x minus 2 and the x plus 1 cancel. I get 2, x minus 1, and x plus 2. Second one, x plus 2's cancel, x minus 2 cancel, so it'd be 2, x plus 1, x minus 1. Third, the 2 cancels, the x plus 2, the x minus 1, which means it's x minus 2 and x plus 1. So from the first one, I'm going to multiply this out, so it'd be 4x minus 1, x plus 2, that's 4x squared plus x minus 2, 4x squared plus 4x minus 8. Second one, I would multiply this out, it's 8, so this is a minus because of this minus. 8, and then x minus 1, x plus 1 is x squared minus 1. So I'd get minus 8x squared plus 8. Last one, 3 times x squared, this is equals now, 3x squared plus, let me work that out, x minus 2, x plus 1, which would be 3x squared minus x minus 2, or 3x squared minus 3x minus 6. Combine my like terms here on the left, negative 4x squared, positive 4x is by itself, 8's cancel. And then I would add this to the other side. And I get 0 equals 7x squared, this should have been squared, squared minus 7x minus 6. So I want to see if this is factorable. I would do first times last. Factors of negative 42 that sum to negative 7. Negative 42 is either going to be 1, negative 42, 2, negative 21, 3, negative 14. 4 doesn't go in, 5 doesn't go in, and the next one would be 6 and negative 7. So I have to use the quadratic here. So negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. 7 plus and minus the square root of 49 minus, this is 28, negative 28 times 6. 48, 168, so negative plus negative 168 over 14. 17, 217 over 14. 217, it's not divisible by 2, it's not divisible by 3, so that would be my solution. Now the only ones that are going to cancel out up here would be a positive 2, a negative 1, there's my negative 2, a positive 2, a negative 2, and a positive 1, which means I can keep that whole solution. All right, so then number 2, we've got 3x minus 2 and 3x minus 2 squared. So my least common denominator is 3x minus 2 squared. I'd get 3 times 3x minus 2 squared equals, one of them cancels, 2 times 3x minus 2. And the second one both cancel, so it's just 5. I can expand and FOIL that first one or use this shortcut, which is what I'm going to do. Square the first one, square the last one, double the product. So negative 6x times 2 would be negative 12x. Distribute the 3 here. Combining those terms. On the left-hand side, well, I'm going to subtract the 6x. Actually, you know what? I would do substitution here. I'll tell you that you can keep going. And you can keep going with those two. Multiply them, find the, first and last, find the factors of first and last that sum to that negative 36. Or, which, again, you can continue to do. I can use the substitution with a here. So if I pull that over, 3 times 3x minus 2 squared minus 2 times 3x minus 2 minus 5, and then a becomes 3x minus 2. So this becomes 3a squared minus 2a minus 5. Factor that. This would be negative 5, positive 1. Yeah. Set them each equal to 0. And I'd get 3a equals 5. A equals 5 over 3. And a equals negative 1. But again, we're solving for x. So I have to then say 5/3 equals 3x minus 2. And 3x minus 2 equals negative 1. Add the 2 here, which would be 6/3. 11/3 equals 3x divided by 3 times 1/3. And I get 11/9. 3x would equal, add the 2, 1, and x would equal 1/3. And again, check those answers. So the only one I can't have would be 2/3, which means both of these are fine. Yep.
Why did you subtract the 6x from the 27x?
Oh, I was here. It would have been the next one. It would have been that. Yeah. And then if you, like I said, if you had continued to factor it, you should have gotten the 11/9 and the 1/3. So you should have gotten the same answers. Okay, then 3 and 4 are your absolute value ones. So the first thing I'm going to do for 3 is get it so that it is completely isolated. The absolute value is completely isolated on the left-hand side. So first thing I'm going to do is add the 3. That's a 3. 3 minus 5x. Then divide both sides by 3. And now I've isolated the absolute value. So I set that absolute value equal to the positive and negative version of that number, which means 3x minus 5, or 3 minus 5x equals a negative 7, and 3 minus 5x equals a positive 7. Subtract the 3. Divide by negative 5. Subtract the 3. Divide by negative 5. Positive 2 and negative 4/5. And then I'm not going to do it now, but plug them back in to check. Okay, we will completely run out of time. Number 4, I've got absolute value equals an expression. The absolute value is already isolated, so I'm literally going to set that absolute value, what's inside it, equal to the positive and negative version of 3x plus 6. So 3x plus 6 I leave, and then x squared plus 2x multiplied by negative 1, and I get negative 3x minus 6. You have to change the signs on both of those terms, okay? You're multiplying the whole thing by negative 1. So now subtract the 3x and the 6 here. I get x squared minus x minus 6 equals 0. X plus 2 and x minus 3. And I get negative 2 and positive 3. Move these over, add the 3x, add the 6, x squared plus 5x plus 6 equals 0. And I get x plus 2 and x plus 3. Negative 2, negative 3. No. Yeah. All right, so now we're going to check those answers. So I'm going to plug them back in. So absolute value of negative 2 squared plus 2 times negative 2 equals 3 times negative 2 plus 6. 4 minus 4, absolute value would be 0. Negative 6 plus 6 is also 0. So that one works. Plug in positive 3. Nine plus 6 in absolute value is 15. This is 9 plus 6, that's also 15. That one works. The other negative 2 we already checked. Plug in negative 3. And I get, look over here, I'm going to get a negative 3. Is there any way to get a negative out of absolute value? No, which means this one doesn't work. So my solutions are negative 2 and 3. So a quick way to work through those is work through the ones on the other side of the equal sign. If I ever get a negative out of that side, I know it can't work because the absolute value is on the other side. Questions on, again, I'll work back through number 1, but questions on the procedure or the process of the rational equations or the absolute value. Okay, so we'll do flip-flop again. We'll do the notes first, and then I'll go back to those homework questions. So they are, like I already have them, they'll be on the video. Okay, here's some homework questions. So this says, solve the equation, check your solutions. For this one, because there's only 2 fractions and one has the equal 0, I would actually move this to the other side. So you'd get x plus 2 over 7 equals x plus 2 over x plus 5, and then cross multiply. So I'd get x squared plus 7x plus 10 here, and then 7x plus 14. Subtract the 7x. X squared, subtract the 10, would equal 4, and x would equal plus and minus the square root of 4, which is plus and minus 2. And then check to see if you can plug that back in. There's only one denominator, so that it's easy to check to see that negative 5 is the only extraneous root. All right, number 13, you've got your absolute value. So I want to set that absolute value equal to the positive and the negative, changing both sides, version of that question. So here I'd get subtract the x and the 1, 0 equals x squared minus x minus 20, negative 5 and positive 4, 5, negative 4. Here I get 0 equals negative x squared minus x. So actually I would have gone the other way, keeping that x squared positive. You can do it that way, but it gets messy. X squared plus x, 1 minus 19, negative 18. There's no factors of negative 18 that sum to negative 1, so you have to do the quadratic. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. 1 plus 72, negative 1 plus or minus the square root of 73 over 2. So when you plug these back in, look at the left, and this would always be positive, which means if I could take and find the right side, x squared minus 19, and see if that's going to give me a negative, I wouldn't keep it. So this would have been 25 minus 19, that would be fine. 16 minus 19, that would also be. This is going to be a negative. So I would rule out the negative 4. And then to check these solutions, so I would use a calculator to figure out what each of those was, like negative 1 plus square root 73 divided by 2 is 3.77, so 3.8. And then negative 1 minus square root 73 divided by 2 is negative 4.8. So then when I check those in this, x squared minus 19, really I need this to not be negative. I need it to be positive. So 3.8 squared minus 19 is going to be a negative. So I rule out this was negative 1 plus square root 73. That's the one I rule out. And then negative 4.8 squared is 23.04 minus 19, and that's going to stay positive. So the negative 1 minus is okay. So I would keep 5 and then negative 1 minus square root 73 over 2. Those are the two that work here. The solution here, they took out the 1/2, but you could leave it in. Number 14, same thing. I'm going to set x squared minus 8x equal to positive. Well, let me do it on the right order. I'm going to set x minus 8 equal to positive x squared minus 8x, and then x minus 8 equal to negative x squared plus 8x. So change the sign on both. Here I'm going to move over the x and add the 8, move over the x, add the 8, and I get 0 equals x squared minus 9x plus 8. That's x minus 8, and x minus 1, positive 8, positive 1. And on the right, subtract the 8, add the 8, subtract the x, sorry, add the 8, 0 equals negative x squared plus 7x plus 8. I did it again, I put the negative on the other side, so let's just do this. Negative x, positive x, and then negative 8, negative 1. That gives me an 8x minus 1, which is at 7x. So I set this equal to 0, negative x equals 1, x equals negative 1, and x equals 8. So now I got to check these. Okay, so I'm going to check. And again, really, I just need to check to make sure this is not going to give me a negative. So 8 squared minus 8 times 8, 64 minus 64, which is 0. That's fine. 1 squared minus 8 times 1, and that's 1 minus 8, which is negative 7. That doesn't work. Plug in the negative 1. Negative 1 squared minus 8 times negative 1, 1 plus 8, and that time it works. So I'm going to keep, and then there's my repeated. I'm going to keep the 8 and the negative 1. So 1, 7 is linear inequalities in one variable. Again, the good news is that this is mostly review, okay? We're solving equations without having an equal sign now. We're having a greater than, less than sign, okay? So the difference between like algebra 1 inequalities and algebra 2 inequalities, the biggest jump is that you're going to learn something called interval notation today. But the process of solving is exactly the same that you're used to. So it's the same rules as equations, except when you're dividing or multiplying both sides of the equation by a negative number. If we do that, then we change the direction of the inequality sign. So if I had 2x is greater than negative 10, let's say, and I divide both sides by 2, nothing changes. But if I have negative 2x greater than 10 and I divide by negative 2, now my sign changes direction. So if I'm dividing by a positive, it's fine, even if the one I'm dividing into is negative. But if I divide by a negative on both sides or a positive on both sides, a negative on both sides or multiply by a negative on both sides, then I have to flip the sign. And then our answers are going to give in an inequality statement, like an x is greater than 3, x is greater than or equal to whatever it is. The graph, which we're going to graph on a number line, and or interval notation. So in WebAssign, it will be easy. It will literally give you the graph. If you want to graph it, it will ask for it in interval notation. If we get to test and it will ask you for interval notation, just think about it before we get there. As we practice it, I'll keep saying test answers are going to be in interval notation, and then you'll also graph them. So this is interval notation, okay? So I'm going to show you all the different cases that could happen. Interval notation is basically a way of showing what the answers can be in terms of numbers instead of x is greater than or x is less than. So if I start with x is greater than any number, okay? Let's say x is greater than a, whatever a is. Then I would plot a on my number line. If it was a 1, I'd put the number before it, so I put 0, 1, 2, like that. And greater than gets an open, you remember open dots on number lines? Do you guys do this before, right? Open dots, interval notation, and open dot is a parentheses. So open dot is equal to a parentheses, solid dot is equal to brackets, if you want to think about it that way. So this would be a parentheses, greater than would point right, everything to the right. That would be the graph of my solution. The interval notation of my solution would be parentheses, a, comma, infinity. So I'm saying start at a, but don't include a, and then go to positive infinity. That's what an arrow does. An arrow is the same thing as saying go all the way to positive infinity. Obviously, we can't give it a number because we don't want it to stop.
So do you put the parentheses or the open dot?
You put parentheses. So from here on out, you're using parentheses or brackets in place of open dot, close dot. But they are the same thing. So if it's less than a number, let's say x is less than a, I put a on my number line. Less than would be a parentheses pointing left. Less than, left. Okay? And the way we write that in interval notation is negative infinity, comma, a, parentheses on the a. So now we're saying go as small as you can go, which is negative infinity, up until that number, but don't include that number. God bless you. Greater than or equal to it says now include that number. So if I said x is greater than or equal to a, I put a on my number line. This time I give it a bracket. Bracket greater than points right. And my interval notation would be a bracket on a to positive infinity.
So it's a parenthesis when it doesn't include the.
Correct.
And it's
And a bracket when it does. So like if you think about the brackets, the top and the bottom of the brackets are almost like equal signs. If you think about it, if it has an equal sign, it gets a bracket. If it's got just a greater than or less than, it doesn't. It gets a parentheses. So if I had x is less than or equal to a, then I would plot a, I'd get a bracket at a, and I'd point it left, and it would be negative infinity to a with a bracket on a. Then I've got a is less than or equal to x, which is less than or equal to b. So there's a bracket, there's a number on both sides, right? So whatever the smaller one is going to go left, whichever the bigger one is going to go right. And it can't equal, which means it's going to get parentheses, and I would shade in between. My interval notation matches that exactly. A, comma, b with parentheses around each. The second one, the next one is almost the same, except this time it's or equal to, so it gets a bracket. It would be bracket A, comma B, bracket. So now we're including those numbers as our answers. And the last one, x is less than a or x is greater than b. If you think about or, the word or, I know like sometimes when we teach this, we talk about like if you're rowing a boat and you had oars, they stick out of the boat, right? They go outside of the boat like that. That's what your graph's going to look like. It's going to point outside. So this would be from A to B, parentheses on the A pointing left because it's got to be less than it, parentheses on the B pointing right because it's got to be greater than that. And my interval notation says negative infinity to a. And you get a little u for union, which means it can be either of these sets. So that little u is called union, okay? But it means either of those sets. An answer from either of those sets works. The next one would be A and B, same, but this time it gets a bracket on each and it points out. Negative infinity to A, bracket, union B to positive infinity. So that's just how you write your answers. Now we do the solving part, right? So we're going to solve it like we would normally solve an inequality, and then at the end we're going to rewrite our answers that way. Yep. All right, so let's start basic, things that we remember, right? So like it says solve, graph, and put in interval notation. Number 1, 5x minus 7 is greater than 3x minus 9. So I'm going to subtract the 3x. I get 2x minus 7 is greater than 9. I'm going to add 7 to both sides, and I get 2x is greater than 16. Divide 2 on both sides. Now that's a positive 2, so nothing changes with my inequality sign. I get x is greater than 8. Okay, that's the actual inequality statement. Now I need to graph it. So I'm going to have like 7, 8, 9. Parentheses on 8 greater than would point to the right. And my interval notation is a parentheses on 8 to positive infinity. Okay, number 2, I would have to add the 3. Subtract the 2x. 5x less than or equal to 10. Divide by 5. X less than or equal to 2. So my number line, 1, 2, 3, bracket on 2, pointing towards the left. Interval notation, negative infinity to 2, this time with a bracket on the 2. Okay, number 3. First thing I would do is get rid of the fraction. I'm going to multiply everything by a positive 2. 2 minus 3x is greater than or equal to 2x minus 8. Don't forget to go all the way to the other side if you're going to get rid of it. Then, add the 8. Add the 3x. Divide by 5. And the x is on the right-hand side of my equation this time, my inequality. So I'm going to flip it around so that when I read it out loud, it makes sense in my head, but also because most of the answers are going to always put the x first if it's multiple choice or something like that. But the little part still points towards the x. So it's still x is less than or equal to 2. This would be a graph. 1, 2, 3. Less than or equal to gets a bracket. Point it left. Interval notation, negative infinity to 2. Bracket on the 2. Good so far? Yeah. Sleepy, but good? Yeah, okay. So I'll work out 4 on the video, but it's the same kind of question. Multiply by 3, get rid of it, move it. This time it's not going to be an or equal to, which means this time it's going to be a parentheses. Yep.
Why would you multiply by?
To get rid of the fraction. For number 4.
Oh.
Just to get rid of the fraction.
I actually did 4's work for 3. That's why.
Oh, okay.
I was like, interesting.
Why does the whole thing get like a bracket? Why only the 2?
So, you mean like not the infinity? So infinity is not a number, right? We say to infinity, but can you give me an infinity amount of, it's not an actual number, which means I can never include it. So good question. Infinity will never get a bracket. Infinity, negative infinity, always get a parentheses. Because you can't include that, it's not a number to include.
Does positive infinity get
Positive and negative always get parentheses. If you put an infinity there, it gets a parentheses. It never gets a bracket. Ever, 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 ever.
Wait, so it's like half bracket, half parentheses.
Yep. Okay, number 4 here. So I would again get rid of the fraction by multiplying by 3. And I get 6 minus 5x is greater than 3x minus 18. Add the 5x. 6 greater than 8x minus 18. Add the 18. 24 greater than 8x. Divide by 8. X 3. And then just reverse it so that it makes sense when we write it out. X is less than 3. So on a number line, 2, 3, 4, less than is a parentheses shaded to the left. Interval notation, -3, or negative infinity to 3 with a parentheses on both. All right, these are compound inequalities, which means you've got 3 parts to it. The middle is greater than half of it and less than half of it, right? So whatever I do to the middle, I just have to do to both sides, okay? So for number 5, the first thing I'm going to do is add 2. I have to add it to the middle and to both sides. I get -2 is less than or equal to 5x, which is less than 9. Notice one side is or equal to, one side is not. They can both be or equal to. They can both be not, or one can, it doesn't matter, okay? Divide by 5 here, and I get -2/5 is less than or equal to x, which is less than 9/5. Now, the only reason I would rearrange these is if the small number was smaller on the other side. Like if this is in order from smaller number to bigger number, right? -2/5 is smaller than 9/5. That's the only reason I would ever switch these around. These look complicated, but honestly are probably the easiest of them because I put them in the order that they give me. The 2/5 gets a bracket, the 9/5 gets a parentheses, and I shade in between. So x has to be in between those two numbers. And then my interval notation is -2/5, 9/5. 2/5 gets a bracket, 9/5 gets a parentheses. Yep.
Why did 9/5 get a parentheses?
Because it doesn't have an or equal to. Okay, I'm going to work through the rest of those on the video as well. I will tell you that, like, if you look at number 8, when I go to solve it, I'm going to have to multiply by -1. And when I do that, all my signs change direction, okay? But I'll work those out on the video. Okay, number 6 here, I'm going to start by adding 1 to all the parts. -2 less than or equal to 6x, which is less than 4. Divide by 6. -1/3 less than or equal to x, which is less than 2/3. So it's in order, smaller on the left, larger on the right. The 1/3 gets the bracket, the 2/3 gets the parentheses, shade in between, and the interval notation mirrors that. -1/3 to 2/3 with a bracket on the 1/3 and a parentheses on the 2/3. Number 7, I'm going to subtract 7 in all 3 spots. -6 less than 2x, which is less than 4. Divide by 2. -3 less than x, which is less than 2. Parentheses on both the -3 and the 2. Shaded in between. -3, 2 would be my interval notation. Eight. Get rid of the fraction again. Multiply everything by 3. -12 less than or equal to 2 minus 3x is less than 15. Subtract the 2. Divide by -3. We're dividing by a negative, so our sign flips. Doesn't change from or equal to. So the one that still has the equal to sign, you're going to keep that equal to sign, but the other one you're going to switch. So now if I put this in order of smallest to largest, I have to switch this order. -13/3 less than x, which is less than or equal to 14/3. So then the answer the number line, negative 13 thirds, 14 thirds. The 13 thirds gets a parentheses, the 14 thirds a bracket, shade it in between, and my interval notation mirrors that, parentheses on the 13 thirds, bracket on the 14 thirds. Because I want to get to this. So absolute value inequalities. I do the same thing we did before with solving absolute value. I want to isolate the absolute value, so if there was a number added after it, I'd get rid of it. If there's something multiplied by it, I'd get rid of it. Then read your statement in your head or out loud. If I read it as the absolute value of, like whatever's in there, is less than or less than or equal to, this becomes an and statement. I put the negative version of the number on the left of my statement, and I keep it all in one statement as an and statement. So x is going to be greater than this and less than this. If its absolute value is great or greater than or equal to, it becomes an or statement. So if you actually say those expressions out loud, less than ends in an, so think and. Greater, if you spell it wrong, ends in or, so it's an or statement. So less than is and, great or is or.
Can you write out real quick what a and statement like would look like?
Yeah, well,
Oh, okay.
yeah, we'll do it. So the first one, the first thing you want to look for is my absolute value isolated? It is, right? If there was a number on the front, I'd divide by it first. If there's a number added to it, I'd subtract it. But this is already isolated, right? So read that statement out loud.
X minus 5 is less than.
The absolute value of x minus 5 is less than 2. This is going to be an and statement. What I do is I take that 2, I make it negative, I put it on the left-hand side. Negative 2. Sign goes in the same direction, so it stays less than. I get rid of the absolute value, and I continue with the rest of my statement. So by adding the negative version of the number on the other side, just like when we set it equal to, we eliminate the absolute value. Now this is x minus 5 is greater than negative 2 and less than 2, because we keep it all in one statement. All I have to do is add the 5 here. And I get 3 is less than x, which is less than 7. On a number line, I get parentheses on both, shading in between, and there's my interval notation. Let me just walk you through this last one real fast. So number 10, if you read that out loud, absolute value of x plus 3 is great or equal to 7, right? So this time when I split it, again, this is an or statement. When I split it, I put a negative 7 on the left. Sign goes in the same direction, so it's bigger to the left. X plus 3. This time, instead of keeping it as one statement, I write the word or, and I finish off with my initial statement. So I split this into 2. Think about your ors on a boat. 2 going on the outside, right? Subtract this. Subtract this. And I get x is less than or equal to negative 10 or greater than or equal to 4. So my graph, bracket pointing left, bracket pointing right, interval notation, and on WebAssign it does a semicolon instead of the U. So if you were writing that out as an answer, I would take either one, but on WebAssign it does a semicolon in between instead of the U.
So when
Okay, last one's here. Examples: solve, graph, and put in interval notation. So for number 11, absolute value is already on the side by itself. This is a less than, so it becomes an and statement. I put negative 4 on the left, less than or equal to x minus 20, less than or equal to 4. Add the 20. And I get 16 is less than or equal to x, which is less than or equal to 24. Set up my number line. 16, 24, brackets on both, shaded between, bracket, 16, 24, bracket on both again. Number 12, first thing I'm going to do is divide both sides by -3, and this switches your sign. So it's important to determine whether it's an and or an or after you isolate the absolute value. Because if I had looked here, it's a greater than statement, which makes it an or statement. But now I'm looking here, it's an and statement. So I do -5 less than or equal to x minus 1 less than or equal to 5, add the 1. -4 less than or equal to x, which is less than or equal to 6. Parentheses or brackets on both of these because it's an or equal to. Shaded in between. Interval notation mirrors that. Okay, number 13, again, same set of instructions. Wait till I divide by -2 before determining if it's and or. Absolute value of x minus 1 is now greater than or equal to -2. So I can continue to go and put the opposite of -2 on the other side, or realize that any absolute value is going to be positive and any positive number is going to be greater than -2. So right there, I know this is all real numbers. And the way we write all real numbers in interval notation is -infinity to positive infinity, and it would be a completely shaded line. Let's say I continued on though. I'd keep it as it's a greater than statement. So actually, let me split this up. Solve this, add the 1, plus 1. And I get an or statement that says x has to be greater than or equal to -1 or less than and equal to 3. So because it's an or statement and not an and statement, it would be the entire shaded line, which would be all real numbers. Number 14, another scenario where it's less than or equal to 0. So absolute value can't be less than 0, but it can be equal to it. So I can say x minus 1 is equal to 0 and x would equal 1. Or less than would be and, put the 0 here, because there's no such thing as plus or minus 0, add the 1. 1 less than or equal to x, which is less than or equal to 1. It can't be less than or greater than, but it can be equal to 1. So this actually would just have a solid dot on the number 1. And my answer would just be 1. 15 now says absolute value again, less than or equal to 0. It can't be less than 0, but it can be equal to 0. So I get 2x equals 1 and x equals 1/2. So 16 is a little tricky because it's a special case. You're saying the absolute value of 2x minus 1 has to be greater than 0. So almost every number is greater than 0. If it was greater than or equal to, well, in absolute value, sorry. If it was greater than or equal to 0, then my answer would have been all real numbers. But really, we're saying every number except what would equal 0. So if I continued and did an or statement, doing 0 is greater than 2x minus 1, greater, so it's or 2x minus 1 is greater than 0, and I solve this, I'd get that x is okay to be less than less than 1/2 and greater than 1/2, which actually means all real numbers except 1/2. In interval notation, that's -1/2 or -infinity, to 1/2 with a parentheses, union, or on WebAssign the semicolon, 1/2 to positive infinity. So again, it's a special case if you can catch it from here. It's really all numbers except what would make this equal to 0. So I could say 2x minus 1 equals 0, 2x would equal 1, and x would equal 1/2. And it would be all reals except that 1/2.